How's everybody doing? My name's Nico. I'm a software developer here at Headway. See a lot of familiar faces, so thanks for coming back. So today we've gotten a lot of feedback from the past meetups on kind of how to continue with this kind of down this path with React for some of the folks that are getting started. And the most common feedback we get is, how do we turn this kind of toy create React app into something more than that, right? So how do we go from, all right, I've done the to-do list tutorial, how do I actually start to build something real, like something with users, or like just start to kind of make this into a more robust thing as someone who just knows React, right? So that's kind of when we got together here at Headway, we decided that the best path forward is just kind of to start doing these kind of piece-by-piece talks and kind of build upon each other, build upon the last talk. So today, we're going to explore kind of the very beginnings of what it's like to interact with a service outside of your React app, right? So how do we actually store data, fetch data from somewhere that's not our own app? So a talk's called React and Databases, and I want to show you. So what I did is, for those of you who were with us in the last talk, we built this to-do list app using Glitch. I've actually moved that code base over to this CodeSandbox environment, which maybe you saw if you were at the testing talk a month ago. So Chris Held used this, and after talking to him, I decided this is where I think we should do all of our future talks on. So I just want to walk through this app real here. So a lot of you will be familiar with this. This is the exact same code base we built, except I've put all the components in this folder here. The form, the title, and the to-do. And so I've kind of initialized the to-dos here in this initial data array, and I passed it into the to-dos here, right? So we are just kind of a standard to-do list app, and the only thing that's missing, so I'm just going to show real quick, I'm just going to do an example, right? So I can submit, I can delete, right? So we have kind of the basic functionality here, but the second that I refresh, it goes back to the initial data, right? So this is kind of where a lot of people kind of say, all right, what's next, right? So I have some state, I know how to manage it, I know how to update it, but how do I actually build something, right? So what we're missing here is just kind of an outside database, right? So we all know what a database is, kind of in the abstract, right? Essentially just a collection of information that's easy to access and update, right? But from React, we don't really, we know what it is, but if you started as a front-end developer, it's kind of a strange subject if you are not familiar with it. So in order to be more productive, or to start to tackle this stuff, we're going to touch upon a couple of non-JS stuff just to know as we move forward and as we start to interact with some of these outside things. So I just want to go over real quick for those of you that don't have any experience with databases. I feel like a couple of things will go a long way here today. So when we talk about databases, I'm going to do a lot of hand waving, just FYI, just to kind of fill some of those gaps. There's essentially two types of databases, relational and non-relational, very high level, right? I just want to talk about the two types real quick. Relational are what most of you think of a database. Think of it as an Excel sheet, right? Just tables and rows. And most of the databases that you are familiar with or that you've used are probably relational. Relational databases use SQL as a query language, which is kind of, for those of you that have used it, it's like the select star from language notation. As different companies, so SQL is like a standardized language, right? And as different companies started to build software to kind of wrap this language, this kind of the raw SQL database and make it easy for users to access it, there started kind of like different dialects started to arise from that standard of SQL, and that's what we now today know as like Postgres, SQLite, MySQL. These are all database management systems that implement SQL, but there's kind of different flavors of the same thing. And that's kind of, it's essentially all the same thing, but just kind of a different flavor of the same standardized language. So that we're all pretty familiar with. The other one is non-relational databases, which are usually referred to as NoSQL. This one, these haven't been as common, but they have been on the rise for the past like 5-10 years. And you can think of it as like kind of big JSON objects. They're like schema agnostic, so you don't need to have this kind of metadata blob behind it before you start to push things up to the database. It allows kind of unstructured data to be stored and manipulated kind of on the fly really quick. So this is very popular with startups that are moving fast. They don't really, the overhead of kind of planning out the entire kind of data model of the whole company before they even push, and like that is a pretty big overhead, and they just want to kind of get going quickly and start to push things up. So you might know some of these. There's kind of multiple types of them. There's key value stores, like Redis and DynamoDB from Amazon are the most popular ones. Those are essentially just like key value pairs. So you just literally just have a key and a value. The database doesn't know what's in it except for the keys, and it has no idea of what the values are. Just knows this is the key and what's stored there, and it's mostly useful for like when speed is the top priority, right? You need to kind of fetch something really fast. Document stores are the other type. MongoDB and Elasticsearch are the most popular ones. These are like semi-structured, so there's kind of a pretty flexible structure, but still JSON form. And even though there's no tables, the database does know what's in those values, so you can query by, some of those values. And then graph databases are another type of non-relational. These are Neo4j is the most popular, and Amazon Neptune is the other one, big one. They represent data as like a network of nodes. So if you're familiar with graph theory, it facilitates visualizing kind of graphs. Most big tech companies kind of keep like social graphs and consumption graphs, so like payment graphs to know kind of what you're spending on, tracking the kind of your individual spending behavior. So just want to go over that real quick. So I'm gonna go back to our to-do list real quick. So the question here is, all right, so so we know like all this, there's many types. What should we actually use, right? Well, we can spend some time kind of setting up like a database management system, or setting up like a server and like all the models to interface with it, or we can just use like a simple document store and get started, as like we talked about, right? Like when you don't really want to set up your entire schema beforehand, you can use a document store and get started pretty quick. So that's why I decided that we can use something called JSONBox, which is it's a service that essentially uses MongoDB under the hood. MongoDB is a document storage, or like a document store service, NoSQL document store. And this is a really nice service that essentially, the second that you go to JSONBox.io, a database is created for you, this endpoint here, is essentially a random hash that gets created every time you go. And this is now kind of our database endpoint. I can go to the dashboard here and show you kind of how it works. So this is essentially a REST API as a NoSQL document store. So what that means is I can create, read, update, and delete resources here really, really quickly. So this gives me like a little playground to make HTTP requests to my endpoint. So just to get started, I'm gonna look at kind of I'm gonna try to build a to-do in my endpoint. So I'm gonna go back here and I'm gonna look at what a to-do looks like, and it essentially has an ID and then text, right? So the ID will be created for me. I'm just gonna send an object, a document with just text in it. I'm just gonna call it first to do. And I'm gonna post it to my endpoint, right? I'm actually gonna call it first document. And then this is what I get back as a response. So it now has an ID and a created on, right? So no schema, nothing. There's just a document is in my store. I can just to show you, I'm gonna do a get to this endpoint, and what I get back is an array with this document in it, right? So I can now retrieve it. I'm gonna create, so like a cool thing that you can do here is, for example, I can create a collection of these documents by simply adding a kind of the collection name to this endpoint. So I'm gonna do to-dos, and I'm gonna post, instead of document, I'm gonna post to-do. So when I post it, the return is again the document I just created. When I do get to the to-dos, I just get the ones that are in my collection. If I remove the to-dos from here, I get all of the things, right? So you can already see kind of how you can start to group these documents super quickly, right? Let's see, I'm gonna just create another one here in the to-dos. I'm gonna do second. Oh, sorry, post. All right, and then if I do get to my to-dos, then I only get the two that are actually to-dos. I can now retrieve and I can create. I'm gonna do an update to one that's already there. In order to do that, I do a put request to the to-dos, and then I have to include the ID of the one that I want to update, right? So I'm gonna copy the ID of the second to-do, and I'm gonna paste it here at the end. And then I'm gonna do second to-do updated. And then I get this message saying record updated, right? And if I get again, not to that one, but to all of them, you can see that the second to-do was updated, and it now has this updated on flag. So the store is kind of doing some things for me in the background, right? And finally, the delete works just like put. I do the to-do slash, and then I'm gonna quickly put this at the back here. And record removed, and just to double check, I'm gonna get my to-dos again. And I only have the first one. All right, so that was just a super quick overview of what a document store looks like and works, right? So, all right, so we can do this here, but how do we actually get this? How do we use this from our React app, right? So let's move over here, and the first thing we want to do is, I guess, we're going to use the same endpoint that we just created. So we have one thing in here right now. So the first thing is, I'm going to remove the initial data for now. Since we're not going to be using any initial data, we're just going to be using our store. And I'm going to change this to just an empty array for now. The first thing is we need a way to actually make these HTTP requests from our React app. There's a really nice library to do this called Axios that we can add as one of our dependencies here. So for those of you that haven't used Axios, Axios is a promise-based HTTP request library. So what I'm doing here in add dependency, that's the same thing as like doing an npm install in your local machine. So now it's in my, Axios is in my package.json now. And I can import it in here. And the way that the Axios API works, what I want to do is, as soon as the app kind of starts up, I want to call for my to-dos, right? So let's make that function that actually does that, right? So let's call that function fetch to-dos. I'm not sure exactly how it's going to look yet or what parameters it's going to take, but what I want to do is I want to fetch using Axios. So let's just do, I'm just going to do the response is going to be, and then the way that Axios works is I just call axios.get, and that is going to make a GET request to the URL that I provide here. So we got to put our endpoint, which is this whole thing, right? And let's see, so this response here is going to be whatever comes back from this, right? Just to actually see what comes back, I'm going to just console log it here so we can actually see what that looks like. All right, so okay, so when do we actually call this function, right? So we have this function, but how do we actually call this when the app renders, right? So if we're using a functional component, so React actually gives us if you were familiar with React before, the component lifecycle methods, this fetching data on render is considered a side effect, right? So it's something that we run when something else happens, or it's not exactly the return value of this render function. So I'm going to include use effect, which is the side effect hook in React, and how that works is it's a function that runs when something else happens. So I'm going to show you what that looks like. So use effect takes a function, and then it takes what's called a dependency array, which tells it when should I run. So that function that we're going to pass it is simply an anonymous function that just fetches the to-dos, right? That's all that it's going to do. And we want it to run only once on mount, right? So in order to do that, the dependency array is going to be empty. So usually you would use a use effect when, say, a Boolean value flips from true to false, or when something gets populated. The variable that goes in here is that thing that you wanted to kind of fire on. But in this case, if we do an empty array, this use effect is going to run as soon as the component mounts. So let's see. So so I just refreshed here, and this use effect ran, and we got something in our console that we console logged here. So let's see what that looks like. Oh, so we got a promise that's pending, right? So this means that the return value, when we console log this response, this Axios is a promise-based library. So we actually have to await for the promise to get resolved. So await is a keyword in JavaScript that stops the execution of this function until we get the response back from the database. In order to use await, you'll see, though, a syntax error here that says that you cannot use the keyword await outside of an async function. So we actually have to wrap this, we have to preface this function with the async keyword, which ensures that this function actually returns a promise. So async, if you're familiar with promises, this is kind of the new implementation of, or this is a solution for the kind of the callback chain or the callback hell, as they call it, where you're doing .then forever. So this allows for this function to actually stop its execution, wait to get resolved, and then we're going to console log here. So you can see now that after refresh, we're console logging this object that has a couple of properties here. Data is one of them, and in the data, we have an array with one thing in it, and that thing is our first to do, right? All right, so now we have data in our app, so let's actually use it. So instead of console logging, I actually want to set the to-dos to this data array, right? So if I do set to-dos to rest.data, I refresh here. All right, we got our first to-do from a database in here, right? But let's actually, let's make this a little bit less. So what I'm going to do is just in case that there's a bad response from the API or from the document store, I'm going to destructure this response object into the data and the status, was it? I believe so. So what this means is I'm going to pull these two values from that response object. So here we can now just do data. But if the status is, so let me just console log that object again. Just show response one more time. So response had a status of 200, right? So that's 200 means everything went okay. So we're actually going to use that status to kind of, before we set anything, we're going to check that status. So I'm going to go ahead and do data and then status. And I'm going to only set the to-dos to data if the status was equal to 200, right? All right. And it still works. OK, so all right. We got to the first piece here, right? So all we're doing is just fetching on mount. We're putting it on here. OK, so the next step would be, or just a little bit of cleanup here. I don't like this like ugly string here. We're going to be using this also when we actually go and delete something, right? So I'm going to turn this into a variable up here. I'm going to just call it endpoint. Right, that's going to be our endpoint. And then here I can just do endpoint plus to-dos. That should still work, right? Just so usually, so this is technically kind of a private key, right? Because this determines your unique database in JSONBox. So, you know, I'll make an exception, but usually this we would want to hide in some sort of environment variable, right? If you're using React. So actually Create React app has a environment variable, the ability for you to set environment variables built in if you preface them with React_app, and then you have your key. So I can actually show that real quick. So I'm going to create a .env file, and I'm just going to do JSONBox key, and I'm going to paste that private key. I'm going to paste that in here. And ideally, you would put this .env in your git ignore so that it doesn't get actually saved anywhere, right? That's the reason for this. so that it doesn't get kind of saved with your code. And in here, I can just do, and this, you'll be able to do this as well in Create React App. I can just do process.env.json, what was it? JSONBox key. Let's see. All right. Sorry? What do you mean? Parents? No. No. Yeah, it might. Yeah. Let me try this. Maybe I had to save the .env. That's probably what it was. All right, well, maybe I'm missing something here, but should work. Anyways. Sorry? No, that should have worked. I tried it earlier, but maybe there's something that I must be missing here. But yeah, I tried to wing it, didn't work. I'm just gonna get rid of that for now. But you get the idea, right? It's just you don't want to have those things kind of in your source like that. So I'm just gonna copy that again here. And all right. Okay, so the next thing here is handle. So let's change now our handle submit so that we actually can create some new things, right? So right now our handle submit is just trying to get this just right. There we go. Our handle submit is checking if the input value is empty. If it is, it just goes to next. If it's not, it creates a new to-do, and then it sets the to-dos, right? So what we want to do for handle submit is make an Axios request, right? So I'm gonna comment this out here for now. And what I want to do, so the handle submit runs when I click submit with the values in there, right? So I'm going to do the same thing that I did in the fetch to dos. I'm going to wait for the response, and I'm going to do Axios. Instead of get, I want to do post. And how post works is it takes the endpoint and then it takes the payload, right? So my endpoint is going to be endpoint. And we're going to post to the to-dos. And then my payload is going to be essentially the input value in the text, and that's it, right? So that's really my payload. I could just make a, I can just do like, and then input value, and then I'll just do my new to-do is what I'm sending over. And then this should come back just like in fetch to-dos, it's going to come in this format, right? The kind of HTTP request default format. So it's going to have a data key and a status key. So I'm actually going to just, knowing that it's going to look like that, I'm going to break it out beforehand here. And let's just do a console log, or actually let's just, the data that comes back, if you remember, is going to be the new to-do, right? So what should we do here, right? So we're going to get back the updated data. Should we Should we push it into our current state? Should we fetch again and just kind of get a fresh, kind of the fresh version of our state, right? So just to keep things simple, let's just, since it's going to be updated up in the server, let's just, as soon as we get back a successful response, let's just refetch the whole list and we'll just re-render it. So that means is if the status is 200, meaning the update was successful, let's just do the fetch to-dos again, right? So that's going to run that function that regrabs the whole thing. Might not be the most efficient thing, but it kind of saves us from like doing all this internal state calculus that right now might be simple, but maybe later on where we're trying to keep, when a bunch of things are changing at the same time, it might be a little more complicated, right? So let's see if that works, right? So the data is not really being used right now, right? All we want is the status, if it actually updated successfully. So I'm going to go and do, let's try this, right? Second to do. I'm going to submit it. Oh, did that work? Let's see. Yeah, that's exactly what happened, right? So this handle submit function needs to be async, right? Because we actually want to wait for this to actually be successful before we fetch, right? So you see how we refreshed and it was there, but when we actually called fetch, it wasn't there yet, right? So let's try that one more time. I'm going to do a third to do. And now when I hit submit, it's coming in here, right? So we see that they're coming in, like they're being successfully submitted, but they're in the wrong order. So we can actually, in our fetch to-dos, let's actually sort these when we fetch them. So we can actually include a sort parameter in the URL. So I can just do, when we fetch, grab them and then sort by. And if we go back here, I want to sort by the created on, right? So I'm going to copy that key. That's what I want to sort on. So now they're in the right order, right? So if I add a fourth to do here, it's not being added at the bottom, right? Also, when I submit, I want to get rid of this. So I'm just going to add here to the handle submit. If it's successful, also set input value to an empty string, right? So that clear that out. Just to check that, fifth to do. All right. So the last thing here for our app is the handle delete. So this is going to be very similar, right? All we want to do is just we're going to get the response. We're going to await for Axios, and the method that we use is delete. And we delete. Delete is a little bit different. So remember when I was showing you the different methods here, to delete, we actually need to put the ID at the end of the resource name. So we're going to do endpoint plus /todos / let's actually change this to and then we're going to do the ID that is coming from here, right? And yeah, we're getting the syntax error that we cannot use await. So we gotta, this has to return a promise. And essentially, from the delete, we received just like a message that says like resource was deleted. So the response is useless. We just care about the status, right? So just same thing. If the status is 200, I'm just going to refetch. All right. So let's see if that works. All right. Cool. So just to show you, so you can actually have multiple document types living together in this same document store, right? So to-dos, they all follow the same kind of structure, right? But I can create another endpoint that we group these documents together. These are going to be users now, right? And I can just have, first name, last name, just an example, right? And these are independent, right, of my to-dos in terms of my store right now, right? They're on a different endpoint. They're grouped in a different collection. So you can see kind of the benefits of this, right? We don't have any schema. We don't have any structure. We're just kind of, to get started, it's pretty great. Yeah, so that's kind of the idea, or kind of the power of this type of database, right? And this still works just fine. It still just gets my to-dos, right? So I'll leave the put or the update as homework. So in our previous talks, we didn't cover the updating locally. So that's not too hard to figure out. So I challenge you to give it a try yourself. Implement that locally and then actually implement it in using the API. So obviously, so just something to keep in mind is, I'm going to just walk through that real quick too. It's like in a React app, you see how your API logic is kind of spread around everywhere. You have these these endpoints everywhere. So what you would want to do, or kind of the best practice, is actually just create kind of like a module for your API and kind of use that kind of like higher level object to actually make your queries. So we have a few minutes. I'll show that real quick here. I'm just going to create an API.js file, which is going to kind of handle all the API stuff so that I don't have to think about that. So I'm just going to move the endpoint there, right? So my app doesn't need to know what the URL is. I'm going to move Axios there. And I'm actually going to just get I'm going to create a quick, let's see, I'm going to do, this API is going to export an object that kind of has like a nice wrapper for me to kind of call on this stuff, right? So the first method here that I want to do is, let's see, let's actually put it up here. So I want to be able to just say create and have it just make it. So the create, I'm going to pass it a new to-do. And what that's going to do is it's going to just return the actual, like the Axios create that we had, right? So this is what I want my create function to do. Return. Okay, and what I'm going to do is I'm just going to export create as a function. Same for these other ones here. So I'm going to refactor this one to just await that create. So I'm going to do import API from API.js, and it's just going to do API.create, and all it needs is the to-do, right? And so you notice how I'm just returning the, so this function isn't async, It's just returning the promise that Axios is going to give back, right? So I don't need to async await here. This is going to return a promise. I'll just async await it over here, right? And the return value is the same. It's just a different interface with this thing. So I'll do the same for the get. So I'm going to do, let's just call it get all, because in the future we might have get a specific one, right? And this one's just going to do return, what was it? Oops. This. And this, we'll export it over here. So now here we can just do await API.getAll. We don't have to worry about anything else. Our API is the only thing. We don't need to know about what is in there, right, from our app. And finally, this one we'll do real quick. I'm just going to do destroy because delete is a reserved word. So I just need the ID and then just return that. All right. There we go. And yeah, so that's kind of how. All right. So did that refactor kind of, did you get the motivation behind it? Just kind of from your app.js, you wouldn't want to know about endpoints or anything, right? You want to create kind of this module that handles all of the HTTP logic and all that stuff. So yeah, that's a very quick, and if you had, your API would obviously talk to other resources, so you could do something like, you know, I would want this to just be for to-dos, right? And then from your API, it would be, let's see, you would do, right? And then your API could actually have kind of a namespace for each resource you have, right? And this still works for everything. Okay, so I know I'm running out of time. So next steps, right? So JSONBox is nice, right? But JSONBox is somebody's side project. Obviously doesn't scale. Do not use this in prod. It is backed, so it is a MongoDB database. And kind of the easiest way, or like a very easy next step, sticking with kind of this architecture would be to use something like Firebase, right? So Firebase is another document store that's super easy to set up. I've actually, I've linked to a really, really good Firebase Starter video that I used a few months ago to get one of my side projects going. There's this guy called Max. He's from Germany, and he's like the best YouTube person like on earth. And he just is like a Firebase guru, and his starter video is like the best one I've ever seen. But yeah, Firebase is very similar to this. There's some local config that you need, but it's essentially very similar to this. You're just kind of pushing up docs and pulling down docs based on the collection that they're in. Let's see what else I got. I'm also linking kind of a more deep dive into the async await and promises, which I think is a very important concept when you're dealing with kind of outside services. So it's very important, very easy to get tripped up, and just getting just like a basic understanding of how they work and kind of the different states that they can be in will save you a lot of headaches as you're working through this stuff. And I'm going to include some CodeSandbox links, kind of the 3 different steps. So at the beginning, kind of where we left off, And then before we refactored into the API.js, and then after, so I have 3 CodeSandboxes there. If you kind of want to do it yourself again, or just want to kind of take it to the next level. But yeah, that's all I got. I hope that was kind of just a 101 on how these things work, how you would actually organize it, and hopefully this will kind of push you to keep going and keep making it more real every time, right? So yeah, that's all I got. Thanks.